Hello everyone. Today I am going to discuss the fifth problem of Codeforces round 929 division 3, which is turtle versus rabbit race optimal training. So what is the problem? So we are given n running tracks. Each track, ith track will contain ai equivalent sections. Okay. So for given an integer u, finishing each section can increase Isaac's ability to by a certain value described as follows. So finishing the first section increases Isaac's performance by u. Similarly, the second section it will increase it by u minus 1. Finishing the kth section increases Isaac performance by u plus 1 minus k. Now here is the one important thing which I missed first time, that the value u plus 1 minus k can be negative, which means finishing an extra section decreases Isaac's performance. Okay. So what is the problem? We are given we are given some value L and U, and we have to determine the minimum R which will give us the maximum maximum sum of performance of Isaac. And if there are multiple R which maximize the increase in Isaac's performance, we have to output the smallest R. Okay. Now the things are given in this order, like the first the integer n is given, and here ai is given, this is q, and for every query we will have some value u and sorry l and u, and we have to find the minimum value of r which maximize the Isaac's strength. Okay, Isaac's Isaac's performance with the given value of u. Now let's take the first example only. Let's take this example. Let me write it here. Okay, so this means that the fast the fast track, there are n running track. The first track will contain 3 sections, the second track will contain 1 section, the third track will contain 4. Similarly, fourth, fifth and sixth contain 1, 5 and 9 respectively. Now what is given for the first test case or first query? We are given L as 1, L and R, L and U. Okay, L and U, L is 1 and U is 8. So the first, let's say Isaac runs 6 sections. So the first, for the first section he will get 8, the increase in performance 8. For the second section he will get 7. For the third section he will get 8, 7, 6 plus 5 plus 4 plus 3, right? 8 plus 7 plus 6 plus 5 plus 4 plus 3, that will be the sum of his performance. Okay. Now let's say the value of 6, this value is not 6, let's say this value is 12. Now the value will be 8 plus 7 plus 6 plus 5 plus 4 plus 3, once again 5 plus 4 plus 3 plus 2 plus 1 plus 0. Now there are 9 values here. Now the value will decrease, his performance value will decrease, minus 1, minus 2, minus 3, like that. Okay, so for L equals to 1 and U equals to 8, let's say what is the answer? Let's check what is the answer. The answer is 3, because let's say he has run the first 3 sections, 3, 1, 4. Then he ran total 8 section. So for running 8 section, his value will be nothing but summation of I from I equals to 8 to 1. Okay, so the value will be nothing but 8 into 9 by 2. Okay, so 36. 36. Okay, so here it is explained that let's say if he chooses r equals to 4, the value will remain same, the value will remain same, 36. So we have to choose minimum r, so our answer will be 3. Now you can take you can check what will be the value of the other test cases. Now let's jump into the solution approach or observations. So our first observation comes from the time complexity. So what is the possible time complexity of this? The possible time complexity here, n is 10 to the power 5, and the sum of n over all test cases is 2 into 10 to the power 5, and sum of q over all test cases is also 2 into 10 to the power 5. So possible time complexities are order of n plus q, or order of n plus q log n, order of n log n, you can say. Okay. Now for what is the observation we can make here? Okay, the observation we can make here is that let's say the summation of a I from L to R, the optimal case, if it is equals to u, the summation of L to R from AI is U or U minus 1. Let's take this as U only, not U minus 1, U. Let's say the summation of AL to AR is 8, then we'll get the maximum value of it, okay? Because this is the first observation, because we'll get 8 plus 7 plus dot 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 plus 1, okay? So it will be nothing but 8 into 9 by 2, 36, okay? Or you can say U into U plus 1 by 2, okay? U into U plus 1 by 2, okay? Now let's say the value of this is, let's say, U plus 1. Let's say the value of this is U plus 1, then also we will get from 8 plus 7 plus dot 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 plus 0, it will be also U into U plus 1 by 2. Here you can see that the value is not getting incremented, or the value is remaining same. But if it is greater than U plus 1, the value will be nothing but from 8 to 0, it will be 8 to 0, and the remaining elements, let's say there are p remaining elements, so it will be minus 1 dot 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 minus p. So the value will be nothing but 8 in U into U plus 1 by 2, U into U plus 1 by 2, and we are also get p into p plus 1 by 2 is getting subtracted, okay? So what will be our algorithm? Okay, so what we will try to do, we'll try to find what is the value of, let's say we have some, let's say we'll try to find summation of AL to something. Let's call it as I equals to L to, let's call it as K. So we'll try to find summation of I equals to L to K. AI is close to, or you can say greater than equals to U, okay? We'll try to find this, and we'll check, let's call the value K. We'll check the value for K and K minus 1. So it is guaranteed that for K we'll get the value of P as 0 or P as some positive integer. So for value of K, if I equals to L to K is greater than equals to U, we will get some K which is greater than equals to, sorry, this p value should be greater than equals to 0, okay? Now for K minus 1, the formula will be nothing but, let's say our U is 8, and summation of L to R is nothing but 4. So the value will be nothing but 8 plus 7 plus 6 plus 5, which is nothing but 8 into 9 by 2 minus, we are subtracting 4 into 5 by 2, okay? Because we are taking all sums from 1 plus 2 plus dot 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 plus 8, and we are subtracting from 1 plus 2 plus 3 plus 4, okay? So we will check these two values, K and K minus 1, and we will compare. If the value of K is greater than the value of value at K minus 1, our answer will be K, otherwise our answer will be K minus 1. So let's jump into the code. So here I am considering the prefix sum. I am building the prefix sum array. Now I am trying to find, let's say we are at some prefix L value. Let's say we are at some prefix L value. We will try to find the index such that prefix R, we will try to find the index prefix R which is greater than equals to prefix L plus U. That's what we are doing. Bisect left in Python. You can use lower bound in C++, okay? Now if R is the last element of the array, we will decrement the value of R by minus 1. Now if R is greater than 0, greater than equals to 0, sorry, greater than 0, we will check R minus 1 also. This case we are checking K and K minus 1, right? So we are checking R and R minus 1. So if R is greater than 0 and R is greater than equals to L, because if L is equals to R, we can't check R minus 1, right? So if R and R is greater than equals to L and prefix R is greater than value plus U. Now I have told you now, if summation AI equals to U, we don't have to check this thing. So that's why we are checking. If it is only greater than equals to U, we are this part I have already explained. We are finding the last is nothing but P. So we are finding the value of total now, and what will be the value of total prep. So total now is the value at R, and total prep is the value at R minus 1. Okay, I have explained it already, so I am not explaining this. Now if total prep is greater than equals to total now, we are decrementing the value of R, and for every R we are printing R plus 1. Okay, I will provide the link of the code in the description box. If you find this video helpful, please like the video and subscribe to my channel. If you have any doubt in any part of the explanation, you can always ask in the comment section.